So I promised that I would do a slightly harder question for the distance between 2 points. So this is the second video. Hopefully you've seen the introduction before this one. And the question says point A has a position vector of, point A has a position vector of -5, 2, and 4. Point B has a position vector of 6, 0, and 6. And point C has a position vector of 8, 10, and 1. So here are three position vectors, right? So if we imagine them in space, they could be here, there, and there, if you can imagine them in 3D. And they ask us, the question says, show that the triangle ABC, so let's say that this is A, this is B, and this is C. Show that that triangle is isosceles. So in other words, the two of those distances need to be exactly the same, and one of the other distance is going to be different. So if I show that two of those are the same and the other one is different to those two, then I've shown what they've asked me, which is that these 3 points describe an isosceles triangle. So for this, we're going to have to use the formula that we used in the previous video, right? And if I was going to do that, I would have to find the vector that points from A to B, okay, which is this one here from A to B. And once I find that vector, which is done by subtracting, this is the original O, subtracting OB, if you do OB minus OA, if you do this vector here, that vector minus OA, you get the vector that points from the head of one to the head of the other. That was all explained in the last video. And so if we get that vector, then we take its own magnitude and we have figured out the distance between the points A and B. So let's do that now. Let's figure out vector AB. And this could be the shorter one or the different one, or it could be one of the equal ones. We don't know. I've just drawn them here without knowing, so we'll find that out. So AB is equal to the vector OB minus OA. Remember that the second one that comes here, the destination one, is the first one that we get here in the subtraction. So that's 606 minus OA, which is -5, 2, and 4. Subtract those two. 6 minus -5 is 11. 0 minus 2 is -2. 6 minus 4 is 2. So this is my vector that goes from A to B. If I find the magnitude of that vector, right, which is done by doing 11 squared plus -2 squared plus 2 squared, and a square root all of that. You can do it in your calculator if you want. You would get, let's see, so 11 squared is 121, plus 4 is 125, plus 4 is 129. So this is the same thing as root 129, and we can keep it like that. We don't need decimals. It's not a perfect square, so no point in putting decimals. Let's see from B to C. So if we want to do now from B to C here, we need to do OC minus OB. If we want to find B to C, right? Second letter, first one here. So B to C, let's see, C is this one here. So that's 8, 10, 1 minus OB, which is 606. And we get the vector for that, which is 8 minus 6 is 2, 10 minus 0 is 10, 1 minus 6 is -5. And the magnitude of that vector is going to be 4 plus 100 plus 25. Square root of all of that. 104 plus 25 is 129. So that's the square root of 129, which is the same as that guy. So actually we just found out that the two equal sides are these two here. Are these two. So these two sides are exactly the same length according to what I've just calculated, and therefore AC should come out to be different. So let's just check that quickly, but AC should be different. So to find AC, I need to do C minus A. So I do 8, 10, and 1 minus -5, 2, and 4. 8 minus -5 is 13. Then we get 8, and then we get -3. And if we do square of 13, we get 169, yeah, and 169 plus 64 plus 9 is not going to be 129, so we've proved that this is a different length. You can finish it off if you want, and that's how you show that the 3 points are describing an isosceles triangle. Very simple. See you in the next video.